Hey everybody, it's Mr. Lowry. Today we're doing some more triangle congruence proofs, but we have two new triangle congruence postulates that we can use to show that triangles are congruent. So yesterday in class we talked about how to use the side-side-side triangle congruence postulate and the side-angle-side congruence postulate to show that two triangles are congruent. Okay. Today, the new postulates that we're going to use are this one, and this is the angle-side-angle congruence postulate. And actually, this is called the angle-angle-side congruence theorem. So actually, this can be proven from this guy. And we did that in class. And if you didn't do that, you can find that proof. If you didn't do that because you weren't in class, you can find that proof on page 208. So I've also kind of marked for you on this page where you can find that information. So real quick, be careful with my camera here. Okay, at the bottom of page 207 you will find the angle-side-angle congruence postulate. Okay, so it says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the whole triangles are congruent. So again, it's a shortcut to showing triangles are congruent without showing all three sides are congruent to all three sides and all three angles are congruent to all three angles. You can do it with less information. You only need three pieces of information as long as it's the right three. Okay? So ASA means that the side has to be right in between those two angles. That's what included side means. Okay, so that's the angle-side-angle postulate. Okay, on the next page, we got the angle-angle-side congruence theorem. Now this is a theorem, so we actually got to prove it. Okay, let's read it first. It says if two angles and the non-included side of one triangle are congruent to the corresponding two angles and side of a second triangle, then the two triangles are congruent. So here, notice you have angle-angle-side. The side's not in the middle. Well, if you think about it for a second, we know that all of the angles of a triangle have to add up to 180, right? And so not too long ago, we proved this thing called the third angle theorem that said if the two angles of one triangle are congruent to two angles of another triangle, then the third angles of those triangles have to also be congruent. So just for like an example, let's say that this was 30 degrees and this was 50 degrees. Well, that doesn't make sense. Let's do 100 degrees. So 30 and 100 degrees. Both of them are 30 and 100. Well, if these are 30 and these are 100, then the other angle has to be 50 to make sure that they all add up to 180. That's kind of the idea. So really what we can conclude here is that angle J and angle C are also congruent to each other because of the third angles theorem. And if we put that extra angle in there, then all of a sudden we have angle-side-angle, which is the theorem that we had, or the postulate we had on the previous page. So this is something that you can use, angle-angle-side is something you can use to prove triangles are congruent, but this theorem we actually have to prove first before we can use it. Okay? The proof is very short. It's right here. Okay? So it starts by saying, look, I got two angles and a side, two angles and a side. The thing is, it's not the included side, right? But when you apply the third angle theorem, which you proved in a homework assignment not too long ago, you know that angle P must be congruent to angle T, because again, all of these have to add up to 180. So if these two guys are the same measure as these two guys, then the third angle has to be the same measure so that they all add up to 180. Okay? So the third angle theorem tells you that you got these two guys congruent to each other, P and T, which gives you angle-side-angle, angle-side-angle. So basically, anytime you have angle-angle-side, you also have angle-side-angle because you can use the third angle theorem to get that other angle. Okay, so pretty short proof, but I want you to kind of understand where that comes from because this is a theorem, right? Before we use it, we want to justify that it actually makes sense. Okay. All right, so that's kind of the two new ones. Now this is a summary, which is also pretty cool, page 209, that says all the different shortcuts that we have to prove triangle congruence. Right? So SSS and SAS were from yesterday. These are the new ones for today. And in your homework, these are the ones that you're going to be using. Okay? So now we have 4 shortcuts. All right. Now that we got the background information out of the way, let's go on to the assignment here. Okay? So again, these are the things that we're going to be using. So what I've done here is I've done the first three. I'm going to walk you through those, and then we're going to flip it over, and I'm going to give you hints on the other three. Okay? All right. So first, what we want to do is just be really thorough, make sure we read all the given, make sure we figure out what we're trying to prove, and then kind of brainstorm and then go from there. So the first piece of information here is that CP bisects angle BCR. Okay, so what we have is we have a segment that's bisecting an angle this time. Okay, now we talked about like a segment bisector in yesterday's proofs, but this is an angle bisector. And if you're not sure about that, then what I would do is I would go to the glossary. Okay, so I have this marked in my textbook, so I can go back to it whenever I need to, and I'm just looking up angle bisector. So the definition of angle bisector is a ray that divides an angle into two congruent angles. So here, PW is the bisector, and it's cutting angle QPR into two congruent angles, QPW and RPW. So the great thing about that definition, knowing that definition of angle bisector, is that we now have some congruent pieces in our triangle, right? So if CP bisects BCR, that means that this angle, BCP, is congruent to this angle, which is RCP, okay? And so that's what I've said in line 2. Now our goal here is to make sure that these two triangles are congruent. That's what we're going to get to, and remember we have these two options. So I'm already on my way, right? I got two angles, or I got a one angle pair, I should say, okay? Okay, so it also, CP also bisects BPR, which is this angle. Okay, so CP bisects that angle too, which means that these guys are congruent to each other as well. Okay, so BPC is congruent to RPC, which is my third statement here. Okay? All right, now notice they both share CP as a side of the triangle, and we know that that side is going to be congruent to itself, and that's the reflexive property of congruent segments. So I got it. That's my angle side angle. Now, when you're using one of these triangle congruence postulates or theorems, you want to make sure that when you use it, you've actually stated the angle, and the side. It doesn't have to be any specific order in the proof, although it has to be in the right order in the figure. Right? It's not just any two angles. It's got to be two angles and the included side if we want to use angle, side, angle. So notice that this is a statement where I got one of my angles. This is a statement where I got another angle. This is the statement where I got a side. And so just based on the fact that I've shown those three things are congruent and I can see in the picture that they're in the right order, I'm going to make sure that this is actually valid. Okay, so I proved the triangle is congruent. Not too bad. 5-line proof. Okay, now the next guy here is slightly different. And what I want you to notice here is that what we're trying to prove is actually that two segments are congruent, right? We're actually trying to prove that this segment is congruent to this segment, okay? Now, you got to pay kind of close attention here because there's lots of different triangles here in the figure, and we got to make sure that we're thinking about the right triangles, because there's these little two tiny triangles, right? These two little like kind of wing guys, and then we got the other like kind of overlapping triangles. All right, so we got to kind of keep that in mind. Well, if you think about it, AE is a side of this triangle, and BE, right there, is a part of this other triangle, right? So those are the two triangles that we're referring to. Let me grab a pen here so I can do the triangles in a different color. Okay, so those are the two triangles we're talking about. Now, the key here, the thing that's important, is sometimes we use triangle congruence to get a side congruent to another side. In other words, if I can show that this pencil triangle is congruent to this pen triangle, then I know that all the corresponding parts are congruent, right? Remember CPCTC? So the idea here is to use a shortcut to show the triangles are congruent to each other, but then use CPCTC to get all the other pieces that we didn't have already, okay? So our goal here, our first goal, even though it doesn't say that in the final thing, we're actually going to show these two triangles are congruent, and that's going to be our strategy to actually show that these two segments are congruent, okay? So let's start out with the given. So we got angle EAD, that's this guy, congruent to angle EBC, that's this guy, and that was marked in the figure. Okay, so that's given. The other thing is that AD is congruent to BC. Now we got to be a little careful here because these tick marks, it's kind of hard to see whether that's marking this piece or the whole segment. This piece or the whole segment. So for that, we have to go back to the given, right? So it's kind of unclear just from the figure, but what they're talking about is AD, this whole piece right here, is congruent to BC, this whole piece right here. Okay, so notice that I got an angle, I got a side and a side. All I need is another angle or another side, really, if they're in the right order and I can show the triangles are congruent. Okay, so I started with my given, and I already had 2 out of 3 pieces of information. From the given, I have an angle and I have a side. Okay. Now, if you think about the overlapping triangles, they share this angle E, or I guess I should call it angle. Oh, I call it the wrong thing in here. Yeah, we can just call it angle E actually, because there's no other angles that are using that as a vertex. So we'll just call it angle E. So since the triangles are both using that angle, okay, that's our other angle. Okay, so what I have here, just make sure I have the right ones. I got angle, angle, side. Angle, angle, side. Okay, so with that, I mean, it looks like I wrote ASA here, and that's true, but in the order that they are in the triangle itself, it's an AAS. Okay, so any angle is congruent to itself, right? This angle is used in both triangles, so we're going to do reflexive property of congruent angles. And then we're going to conclude that those triangles are congruent. So by angle, angle, side, angle, angle, side, these 2 triangles must be congruent. Okay, great. So I proved the triangles are congruent in step 3 by AAS. Okay, but that's not my last step, because really I wanted to get AE congruent to BE. But here's the thing. Remember that when you show 2 triangles are congruent, which is what we did here, you get 6 pieces of information. You know that all the corresponding parts of the congruent triangles are congruent, and that's what CPCTC stands for. So now that I've got the triangles are congruent, I know that this side's congruent to this side, and I know that basically all the sides are congruent. This side's congruent to this side, and I know all the angles and everything. I got all 6 pieces. Well, I already had some of those, right? But now I have the other 3. So now I can conclude that AE is congruent to BE by CPCTC. So if the parts that you're trying to prove are congruent are part of 2 triangles, then show the triangles are congruent first, and then use CPCTC to get all the pieces of that triangle have to be congruent to the corresponding pieces of the other triangle. All right, that's kind of the mission. Now you'll see that a lot of the proofs on the back of the assignment here, the end goal is not triangle congruence, but you're going to use triangle congruence in that process. All right, let's continue on to number 3. All right, so in number 3 here, we want to prove, actually in this one we do want to prove triangles are congruent, so that's okay. And so we got triangle GJK, that's this guy, and triangle JGH, that's this guy. We want to show these 2 triangles are congruent. Okay, what's given is that we have 2 sets of parallel lines. Now in some of the proofs yesterday we only had 1 set of parallel lines. In this one we have 2. So we're actually going to have multiple sets of alternate interior angles here. So that's where I started, okay? So I'm just going to extend this line out a little bit just so you can see what's going on here, okay? So for this guy, I'm going to have alternate interior angles are congruent. Now you got to be a little bit careful here with that theorem, because notice that these 2 parallel lines give me these alternate interior angles, and the other set is this guy right here and this guy right here. And notice that the angle of I guess this is a parallelogram, does not match the other alternate interior angle that I get from this and this line. Okay, so if we only had 1 set of parallel lines, we wouldn't be able to say that these 2 angles are congruent. If we only had that 1 set of parallel lines, we could only conclude that these 2 are congruent, because the other set of alternate interiors actually go outside of the shape. However, in this case, we have another set of parallel lines, which is great. So for these guys, we also have parallel lines and a transversal, which gives us these alternate interior angles. So now these guys are congruent because of the other set of parallel lines. All right. So when you have one set of parallel lines and you have like a parallelogram, you can't get both alternate interior angles. You have to have two sets of parallel lines to do that. In this case, we do, so that's great. So what I've said in step 2 and step 3 is I've just stated those angles. So K, G, J, that's this guy right here, is congruent to H, J, G, that's this guy right here, and that's from these parallel lines. And then the other statement, statement 3, I have K, J, G, this one, is congruent to H, G, J, that's this one. So these two guys here come from this set of parallel lines. Okay, I'm still using the alternate interior angles theorem to get both of those though, so that's how I got those. So now I got angle, two sets of congruent angles, which is good, and then of course the triangles share this side, and so we're going to use the reflexive property of congruent segments to say that this is congruent to itself. So that got a little messy. Let's clean it up a little bit. I'm going to switch to pen so you can see better. Okay, so we know this angle is congruent to this angle. That was actually, I did that in step 3. That's because these two lines are parallel. I also know that this angle is congruent to this angle. That's actually I did in step 2 because these two lines are parallel. It doesn't actually matter the order that you say those in. And then this segment is congruent to itself. Okay, so what I have is angle, side, angle, angle, side, angle. I got two angles and an included side of one triangle congruent to two angles and an included side of another triangle. And so I can include the triangles are congruent by ASA. Okay, so that's the first little bit here. I'm going to go in the next video, I'm going to flip it over and we'll kind of run through some key ideas for the proofs. I'm not going to write out the whole proofs for you. I want you guys to practice that. But now you've got several examples of how to go about it. And the thing I think that's really important from this page is this idea right here, using CP/CTC. How does it work, right? Well, again, if you want to prove two segments or two angles are congruent, see if they're on a triangle, right? Since these two segments are part of two triangles, if I can show the triangles are congruent, then I can use CP/CTC to show that the sides are congruent. And that's a big strategy for the back page. Okay, thanks for watching. Check out the next video if you want some hints on 4, 5, and 6.